Okay, welcome back to another video of Mr. Dahlstrom's pre-AP Physics class. This is for my at-home learners or anybody else that's welcome to watch these videos. Today's short little lesson, or not a short little problem, just one problem today, comes from our free fall number 2 worksheet. I'm not Spanish, I just like to put little weird things from time to time on there. This comes from our free fall number 2. It is the number 1, so I'm going to read it from here. Excuse me, but I will do it on this piece of paper just because there's more room to show you visually. So this one here is a little bit different because of what they're asking us compared to the problems that we've already looked in the past video, free fall number 1. It says a physics teacher is thrown vertically upwards with an initial velocity of 24 meters per second. At what height is his speed 8 meters per second? And that's not a typo, that's speed, 8 meters per second. And at what times, that's also not a typo, is he at this height? So let's think about, like, why are they asking us specifically about, why are they saying speed and why are they saying times? So basically, if the physics teacher is thrown up here and then comes down there, we're obviously the teacher would go straight up and go straight down, but I'm just showing this sideways movement just for the sake of giving us more room to look at here. So there's basically going to be some point in this arc of moving up and down. If the initial velocity here is, in the y direction, is 24 meters per second, then he's eventually going to slow down. At this point, way up here, the velocity is 0 because it's the max height, and then it comes down and for that. So there has to be some point here where let's just say at this point here, where we are calling the final velocity, where the speed is basically going to be the 8. Remember what speed means? Speed is how fast, but velocity is which direction. So if the teacher is still going up at this point, the velocity at this point would be 8 meters per second. But also, there's going to be a point where it is 8 meters per second coming down. And that point is exactly opposite over here. There's a point where at this point, the velocity is negative 8 meters per second. That's why it asks, at what height is his speed 8 meters per second? Because he has a speed of 8 there and a speed of 8 there. The velocity is positive 8 because it's still going up. The velocity is negative 8 because the teacher is now going down at this point. But we'll use that to figure out the first part, at what height is his speed 8 meters per second, and then we'll do the times. So let's go ahead and fill out what information we know down here. So once again, we're trying to figure out what delta y is, the height, specifically the height when the teacher is launched up at 24 meters per second, and not when it's at its max height where this is 0, but at the point where it's going positive 8. Now you may ask, well, why aren't we using negative 8? We'll see in the equation here that it doesn't matter if we use positive 8 or negative 8 to get the answer. We'll end up squaring it, and it'll always be a positive answer. G is gravity, so we know that's negative 9.81 meters per second squared. And of the 4 equations that we have, you should be familiar with these, or at least have the notes from you. The only one that doesn't have time that allows us to solve for delta y is going to be what we call in my class the 4th equation, which is VFY squared equals VIY squared plus 2G delta y. Now here's the reason why it doesn't matter whether we use positive 8 or negative 8, because when we plug that value into here, we end up squaring it. So positive 8 squared is 64, negative 8 squared is also 64. It's kind of a cool little thing how the equation works. Sorry, there's the bell. I'm using my prep period for this. So I'm just going to go ahead and use positive 8 because, like I said, it doesn't matter. The initial velocity down here is 24. Square that. Plus 2 times negative 9.81 delta y. When we do that, let me go ahead and grab my calculator real quick. All right, by the board, we're solving it here, so what we're going to do here is we're going to square. So 8 squared, subtract 24 squared, 2, 1, and we should get a delta y that is positive 26. We've run out the 2 decimal places. 26.10 meters. Now remember, that means that's not only 26.10 for this one, but like you said, if you put -8 squared here to figure out how far that is, just the displacement, we're not talking about the distance, the arc, we're talking about just from here to this point is 26.10 meters. So there's the first part done and solved. The second part is, and at what times is he at this height? You may say, well, wait, what do you mean by that? Well, if I use my marker here, one of the times is going to be basically just going up to this point. Okay, that's going to be the shorter of the times. The other time is going to be going up, reaching its max height, and then coming back down again. That's the other height. So we should expect the one where it's coming down to be a longer time. So if we look at what we have, in terms of this, yes, we have delta y, but we didn't actually need delta y to solve for this. If you look at what we have here, and I'm going to go ahead and use an equation that doesn't use delta y, we have initial velocity, final velocity, gravity, and we're trying to solve for time. So what we call the second equation in my class, this is VFY equals VIY plus GT. Basically, there's two scenarios here. We're going to figure out what is the time for the first scenario, and then what is the time for the second scenario here. Okay, both the second equation. So for basically the blue scenario and the red scenario, once again, we should expect the red to be longer because it takes a longer path. And okay, here we go. So final velocity, remember we're doing this. This is where the final velocity in the y direction is +8. This is where the final velocity in the y direction is -8. Okay, so here we have +8 equals initial velocity of 24 plus -9.81 times t. And then down here we would have -8 equals 24 plus -9.81 times t. Now when you solve for this, we get actually interesting numbers where you might think that there's some kind of solution here that's always going to be the same. So take 8 minus 24 divided by -9.81. I get a time of approximately 1.63 seconds. Okay. And when I find the other time, I take -8 minus 24 divided by -9.81. I get 3.26. And if you look at this, this number is exactly double this one here. Is that a coincidence, or is that something that is always going to happen? In this case, it is a coincidence. The reasoning behind that, I was kind of looking at this earlier here, is basically what's happening in this scenario here. So in one way of looking at it, in the kind of blue scenario here, we're taking 24, the difference between 24 and 8. So in some ways, 24 minus 8, I know I'm kind of rearranging here, and that is 16. But in this scenario, because we're subtracting this, we're basically taking 24 plus 8, and that equals 32. And the fact that that's double of that, that's why that's the case. So if you plugged any other number into here, let's say we did 5 instead, it said 24 minus 5, and 24 plus 5. 24 minus 5 is 19. 24 plus 5 is 29, and we can see that this is not double that. So the fact that the problem shows 8 meters per second was probably there to show that this is the point where it takes double the time than here. But any other point, it would not have this doubling impact. So that's the problem there. I want to try to keep this under 10 minutes, but those of you that are working from home, expect this worksheet to be on the folder in Schoology. And so I appreciate you checking this out, and I'm going to go ahead and sign off. Thank you for watching.